first questions here, all they want us to do is expand what is written. Okay? So, if we are taking something to the third power, what does that mean we're doing? Right, that many times. Right? So, if I was to expand t to the third, it would really be t times t times t. Right? Alright, and I'm also supposed to be multiplying this times t to the fourth, which would be how many t's multiplied together? 4 t's. Okay? So now that I have it written all out here, how many t's do we have? 7. So this is equivalent to t to the 7. Alright? On number 2, I've got 5 times s squared. What does s squared mean I have? Good. Times 6s to the 6. How many do we have there? 6. Okay. All right, so how many s's do we end up with? 8. So I've got s to the 8th, but I also have 5 and 6. So what is 5 times 6? 30. So I have 30 s to the 8th. Okay, so based on what we just did here, what are we going to do with our exponents to come up with our answer? What did I do with my exponents to get 7, 3, and 4? Added, right. Here, 2 plus 6 would give us 8. So anytime you're multiplying and you have that common base, you just add up your exponents. But if you've got numbers, we still multiply those just like we always would. Okay? So that's basically what this part right here says. To multiply powers with the same base, we just add the exponents. So as long as you have the same number as your base or the same letter as your base, you just add whatever your numbers are. Okay? Okay, so on this example here, I've got x to the 2nd times x to the 3rd. What do I have? X to the 5th. Good. All I do is add my 2 exponents. Okay? All right, so on number 3, I've got 2 to the 3rd times 2 to the 4th, right? All I'm going to do is add the exponents. So this is going to become 2 to the 8th. Okay? Now, if I wanted to actually see what that was, 2 to the 8th, I can type that in my calculator, right? That means 2 times 2 times 2 times 2 times 2 times 2 times 2, right? All those times. Now, if it's a variable, we can't type that in our calculator because we don't know what the base is. So we have to leave it like this if it's a variable. All right? Number 4. First, in front of the exponents, there is some number, right? Those are not being raised to any exponent, right? Only the ends have exponents. So the numbers I can multiply together. What is 2 times 3? 6. And I'll have n to the 9th. Good. So I'm just going to add those exponents of 5 and 4. Okay? On number 5, they didn't put the dot in between, but they have parentheses, so still just normal multiplication. I can multiply the numbers in front of the variables. So what is 14 times 2? Good. All right. Now I've got some variables, but they don't all have the same base. Remember, we can only use this rule if they have the same base. So I've got an x squared. Are there any other x's? No. So x squared just stays x squared. There's nothing else like it. Okay, I've got a y to the fourth and a y to the third. That's going to become y to the good. Okay. And then we've got number 6. So this one's multiplying 3 terms. So again, we start with those numbers in front of the variables. I've got 10 times 3. What's that? 30. 30 times 2. Good. All right, and remember, we can only do bases that are the same, right? So I have an x here. Does it have an exponent written? No, so what's its understood exponent?
1.
Very good. So I got a 1 here, okay? What's my exponent for the next x? 1/2. So I'm going to add a half. And then what's my exponent for the last x? 2. So I've got 1 plus a half plus 2. What's that going to give me? 3 1/2. But we can't have this as an exponent. So I need to turn it into an improper fraction. So you can do that 2 ways. If you just typed this in your calculator, it may go ahead and do it for you, right? It'll make it an improper fraction. If not, you can always, remember, you multiply here to here, which would give you 6, and then you add your top number, which would give you 6 plus 1 is 7. So this would become 7 over 2. You keep your denominator. If you don't remember that trick, you could just have added these 3 numbers in your calculator, and it would have given you 7 over 2. So I would have x to the 7 over 2. All right, now I got to go back to my y's. So what's my exponent for the first y? Okay, so I've got 9 over 2 plus, what's my other y's exponent? 7 over 2. So if we want to add fractions, we have to have a common denominator. Do these have a common denominator? So we can go ahead and add the top. What is 9 plus 7? 16. So we got 16 over 2. Can I simplify that to 8, right? Because it's just dividing by 2. So I got y to the 8. All right. Okay, and then we've got number 7 here that wants us to find the area in square units of some rectangle. I got my rectangle here that has a width of 2x squared y squared and a length of 4x to the 5th y to the 1/3. Okay, so we said last week that to find perimeter, we added up all the sides, right? To find the area of a rectangle, what do? What's the formula for that? Length times width. Very good. So area equals length times width. And do we know the length and width? Yeah. So I'm just going to take them and plug them in. So for length, I'm plugging in 4x to the 5th, y to the 1/3, times my width, which they said was 2x squared y squared. Okay? If you're choosing not to take notes, that's fine, but you're not allowed to ask me a question when it comes time for the assignment. So I've got 4 times 2 out in front of each. So 4 times 2 gives us
8.
Right. I look at my x's. My exponents are 5 and 2. Right. We took this and added them together. Remember, if you want it to go ahead and just give you the improper fraction, add them in your calculator. 1/3 plus 2. Right? So 1/3 plus 2 does give us 7/3. So this would be my area. All right, so that's our first law. Anytime you multiply common bases, then you can add their exponents. Okay. All right, flip it over onto the back, and we've got our second rule. So this one, again, first thing they want us to do is to expand it. So b to the 5th means I have b times itself how many times? So I got 1, 2, 3, 4, 5 b's in the top, and how many in the bottom? Good. All right. And we know when we divide, stuff cancels out, right? So those would cancel each other out, and those would cancel each other out, but is there anything else in the bottom? No. So how many b's did I have left in the top? So I got b to the 3rd, and there wasn't anything left in the bottom, so it's an understood 1, right? But do I have to put b to the 3rd over 1? No, it's the same as just b to the 3rd. Okay? All right? So same idea on number 9, that's just flip-flopped, right? It's got the 2 b's in the top this time and 5 in the bottom. We're still going to have some that cancel out, right? Okay, so are there any left in the top? So what's understood to be in the top? Good. And then what's left in the bottom? Okay. But I can't get rid of the 1 because the 1's in the top this time. It has to stay a fraction, right? Okay, so what did we do with 5 and 2 to get 3? Subtracted, right? Same thing over here. 5 minus 2 would give us 3, right? The difference is that you're always going to put it wherever the bigger number was. So the 5 was bigger, so we put our b to the 3rd in the top where the 5 was. Here, the 5, which was bigger, was in the bottom, so that's where I have to put the number I get when I subtract. So always put it where the bigger number is, okay? All right, so that's what this rule is telling us here. As long as our bases are the same, we can subtract. So they give us a couple of examples. So on this one, my exponents are 4 and 3. What do I get when I subtract? 1. So where was the bigger exponent? Top. So it's like 3 to the 1st, right? And you can put it over 1, but you don't have to. Okay, so this is really just 3. Okay? All right, on this next one, again, I'm going to subtract my exponents. What's 10 minus 3? But where was the bigger exponent this time? So I have to put a to the 7th in the bottom of the fraction. So what am I going to put in the top? Good. Nice. So remember, when you subtract, leave the term where the bigger exponent was. Yes?
So if you have like one variable that's still there, would that be 2?
So like if there was still like an extra b in the top, so you would just have b in the top. You wouldn't have to put the 1 because there's something else to hold the spot up there. We just can't leave it blank, so we have to fill it in with the 1. Good question. So when you subtract, leave the term where the bigger exponent was. Okay. All right, so now we're going to try out our rule on a few more examples. Remember, we can only use this rule if the base is the same, right? So on example 10, I can only subtract x's with x's. So in the top, we've got an exponent of 3 for x. What's my exponent in the bottom for x? 1. And when we subtract, we would be left with just 1, right? And where am I going to put it? Top or bottom? Where was the bigger exponent? 3 or 2? 3. So in the top. So I have an x to the first in the top. All right? For y, my exponents are 5 and 2. So when I subtract, we get, and where are we going to put it? Top. Now, do I have to write this exponent of 1 with x? No, it's understood, right? So I don't have to put that there. I can just write this as x, y to the third. All right? Number 11. So we've got numbers first. Remember, we treat those like usual. So what is 8 divided by 2? 4. Okay. Then I look at m. My exponents for m are 5 and 8. When I subtract, I get 3. And where was the bigger one? In the bottom. So in the bottom of the fraction, I'm going to have m to the third. Okay? For n, when I subtract my exponents, what do I get? And where do I put it? So my answer would be 4 over m to the third, n to the third. Okay. All right, number 12. So here we've got a couple things going on. We got multiplication and division. So I'm going to take care of the top row first before I ever try and divide. So we're going to ignore the bottom for right now. In the top, if I multiply 6 times 3, what are we going to get? Okay. And what do I do with my exponents when I multiply? Add them. So for a, I've got 4 and 2, so I end up with a to the, good. Okay, and it's still over to a to the 5 halves. All right, now we're going to divide. So in the top, we got 18. In the bottom, 2. What is 18 divided by 2? Good. Okay. And then for a, what am I going to do with my exponents? Subtract. So I've got 6 minus 5 over 2. And what is 6 minus 5 over 2? 7 over 2. Which one's bigger, 6 or 5 over 2? 6. Okay. If you don't know which one is bigger, turn 5 over 2 into a decimal, and then you would be able to tell, right? You can just type that in your calculator and convert it to a decimal. So we have 9a to the 7 over 2. Okay. Number 13, again, we got multiplication and division, so we're going to work through the top first. So I'm ignoring the bottom right now. What do I get when I multiply -3 and 4? Good. All right, and what do I do with exponents when I multiply? You add them. So for m, I've got 3 plus what? 1. It's an understood 1, which would give me m to the, right, because n also has an understood exponent of 1 there at the end. So 2 plus 1 would give us n to the third. And this is still over 6m squared n cubed. Yes, we need to divide our numbers first. So we're dividing -12 and 6, which you said would give us -2. And then what do we do with our exponents when we divide? Subtract, right? So now we just subtract our numbers. But that's not what this is a number, right? This isn't an exponent. So we're not using exponent rules on just plain numbers, okay? If it was flipped over, 6 divided by 2 is a fraction or decimal, right? So then you would put it in the bottom. Okay? All right. So for M, we're going to end up with, and where are we going to put it? Good. And for N, what are we going to do? Right. 3 minus 3 is 0, right? So they kind of just cancel each other out. There's no more. Right? 3 minus 3 is 0. So this would be my answer. Okay, last one. It says that the area of a parallelogram is 36 x to the 8th, y to the 7th square feet. The height h of the parallelogram is 9x cubed, y to the 5th. The area of the parallelogram can be found using this formula. Find the length of the base b. So they said find b. All right, so I've got this formula here. The first thing in the formula is a. Did they tell us a? Yeah, so I'm going to plug it in. So I should have 36x to the 8th, y to the 7th equals b. Do we know b? No. So I have to leave that as a variable. Times h. Do I know h? Yeah. So I'm going to take this and plug it in over there for h. So I've got b times 9x to the 3rd, y to the 5th, right? So all we've done so far is plug in what we know. Okay. So we are trying to solve for b. Right now, b is being multiplied by all that. So how would I get rid of multiplication? Divide. So I want to get rid of all this, so I'm going to divide by it. And if I divide one side by something, right. So I also have to divide this side by 9x to the 3rd, y to the 5th. So those will cancel out on that side. And now we actually have to divide over here. Okay, so what is 36 divided by 9?
4.
Good. Okay, and then for x's, if I subtract my exponents, what do I get? And where do I put it? Good. And then for y, what do I get?
2.
Where at? Nice. And that should be equal to, all that was left on that other side was b. All right. So there's my base. All right, so if they give you something, all you have to do is plug it into the formula and solve for whatever piece they don't give you.